All right, so here's number 5 that we didn't quite finish in class. So we're going to do this in 2 different ways. We're going to go ahead and do this one exactly as it's written first. So I've got an inside function here and an outside function here. And so that means I'm going to use chain rule first because both pieces on the inside have the same power. And we're going to start out with f prime of x equals, bring down my 4, leave the x to the 1/2 because we're thinking of this square root of x as x to the 1/2. Times the x squared minus 1, all of that stays, and our new exponent is 3. Then we're going to multiply, chain rule says, by the derivative of the inside. And I'm going to put that here. Now that's going to be a little bit complicated because my inside is 2 things that are being multiplied together. And because it's 2 things that are being multiplied together, we're going to start with product rule. So that means for product rule, I'm going to make this my function 1, and I'm going to make the x squared minus 1 my function 2. And my function 1 is going to be the x to the 1/2, and its derivative is 1/2 x to the minus 1/2. My function 2 then is the x squared minus 1, and its derivative is 2x. Now from here, we're going to execute our product rule. So 1 prime 2 is your 1/2 x to the minus 1/2 times x squared minus 1.
It's going to be me and Nelly.
Plus, and then we're taking 1, 2 prime. So 2x x to the 1/2. And we'll handle multiplying that out in just 1 second. And of course, that's going right in that spot that we designated for the derivative of the inside. So from here, okay, we're going to rewrite this. So the first part's going to stay the same. X squared minus 1, everything cubed. Now let's go ahead and distribute here and combine our like terms so that we have parentheses. 1/2 times 1 is 1/2. Keep my x, and now I'm adding exponents here. So negative 1/2 plus 2. If we had 2 oranges and cut them each in half, we'd have 4 halves. Take away one of those gives us 3 halves. Then you're distributing to the second term. So 1/2 x to the minus 1/2 times negative 1 is negative 1/2 x to the negative 1/2. Plus, now in this last term, there's a 1 there on that x, so we just don't write it so that we can see it there, so we can add them. So the 2 stays where it is, and then I've got 2 x terms, and I'm multiplying them, so I'm going to add their exponents. So my 1 orange cut in half gives me 2 halves, plus an extra half gives me 3 halves. It's not uncommon that we get that 3 halves from 2 different parts. Okay, that happens quite frequently. And then we're going to go ahead and add these 2 terms together. Okay. So that first term stays the same. So 4 x to the 1/2 x squared minus 1, everything cubed, times. Now I am adding those 2 highlighted pieces together. Ooh, I missed something here. Hold on, let's fix that. I lost my x. So that is 2x to the 3 halves. There we go. And now let's highlight it back where it was. So I'm adding those 2 things together because they are like terms. They have the same x part. And we're adding the 2 numbers in front. Add the coefficients, the 2 plus 1/2. So if I have 2 oranges, cut them in half, that's 4 pieces. Add in the extra half, that is 5 halves, x to the 3 half. And then that last term in the middle, minus 1/2, I'm going to move that x to the 1/2 down with the 2. That way I can make that exponent positive. And that would be my final answer. So that's one way to go about it. So if you just jump in the way that that function is written, use your chain rule, and then use your product rule, you'll get this as your answer. Now, there is an easier way to go about this one, and so let me show you that as well. So, or we could say that f of x here is, and I'm going to switch that square root to a 1/2 power, all to the 5th. Now, I have a power, and I'm multiplying 2 things to the same power. So I can actually distribute this to both terms. And then when I do that, when we take powers to powers, we multiply them. So in this case, I would be multiplying the 1/2 times the 4 to get an x squared there. And then this one would be x squared minus 1 to the 4th. And the benefit to doing that is that it gets rid of your fractions. So you have less to worry about with the fractions. I'm still going to have to use both chain rule and product rule. And in fact, now I'm going to use the opposite order. But it does eliminate the powers, like that fractional power. So in this case, my two pieces that are being multiplied now have different powers. So I'm going to start with product rule. So this is my function 1, and this is my function 2. So function 1 is x squared, and its derivative is 2x. Then function 2 is the x squared minus 1 to the 4th. And in order to get its derivative, I've got my inside and my outside, so I'm going to need chain rule. Okay, so my inside is the x squared minus 1, and the outside is the 4th power. We're going to bring down that 4th power. Our x squared minus 1 inside stays, and my new power is 3. We decrease it by 1. Times the derivative of what's in yellow, the inside. So the derivative of x squared minus 1 would be 2x. And then I'm going to put these two things together. So that's going to give me 8x times x squared minus 1 cubed. Now that I've got everything set up, I can go ahead and put this all back together using my product rule. So f prime of x is going to be equal to 1 prime 2 is 2x times x squared minus 1 to the 4th plus these two multiplied together. That's going to give me 8x cubed times x squared minus 1 to the 3rd. Now, if I want to make this pretty, I can go ahead and factor some things out. So I've got 2x and 8x cubed. And I've got the x squared minus 1s. So if I look at the 2x and the 8x cubed, I can bring a 2x out front because they both have that in common. And then I can bring out the x squared minus 1. And both terms have at least 3, so I can factor out 3 of them. What's left behind that, I took the 2x and x squared minus 1, 3 of them out of that first term on the left. So there's one x squared minus 1 left. Now that does have 2 terms, but I'm not multiplying it by anything, so I don't have to put it into parentheses. You can if you like, but you don't have to. And then when you look at that second piece, all 3 of the x squared minus 1s moved to the front, but only 2x moved of that 8x cubed. So if I take out the 2x, if I take 8x cubed divided by 2x, that's going to give me 4x squared. And that means that my final answer here is going to be the 2x times the x squared minus 1 cubed. And then in here I can combine the like terms and make this 5x squared minus 1. And that's my final answer. And so my answer is a little bit cleaner. Now, are they equal? Yeah, they are. I could, if I worked hard enough, use some algebra up above to show you how these two are exactly the same. And I could get that one to look like this one. But, excuse me. So they are equivalent, but I don't need them to look the same if I don't want them to. So you could use either strategy here. Personally, I like the second one because it's less effort with the fractions, but you don't have to do it that way. Okay, either is great.